Hi, in this video we will do some examples of finding the domain of given functions. Um, First, you should remember two things while trying to find the domain. There are two restrictions that we have to keep in mind. One, the denominator cannot be 0. Two, under the square root cannot be negative. And these two are basically the main source of finding the domain of function. Okay, so see what we have here. So this first function is rational function. Numerator is nice, denominator is nice, but we have to make sure that the denominator is not 0. So zeros of the denominator is what we need to be careful about. Okay, so this is this is a quadratic equation. You can use quadratic formula, or the decomposition you can use here is that sums of two things, -5, the product is +6. So these two numbers will be two numbers you're looking at. Then you have two factors, two numbers, two expressions multiplied equal to 0, then each one can be 0, or either one needs to be 0, and that means that x can be 2 or x can be 3. What does this mean? This means that the domain of this function f is the whole real numbers, but 2 and 3. Exclude 2 and 3. The interval notation of this will be from -infinity up to number 2, then jump the number. So this is the union 2 to 3, union 3 to plus infinity. That's the domain of that rational function. Here we have the square root of x cubed minus x. We have to make sure that under the square root is not negative. In other words, it needs to be bigger than equal to 0. To solve inequalities of this form, always remember we have to use sign table. So to find the sign table, we start with setting this equal to 0. Let me first write this. Use the sign table. Sign table is saying where this expression is positive, where it is negative. Well, to do that, the first step is that find where this guy is a 0. Or 0 is where the sign changes, or it may change. And don't try to solve this. Well, I can factor this x and then get x squared minus 1 equals to 0. And then factor x squared minus 1. A squared minus b squared is a minus b times a plus b. So we'll have x times x minus b x plus. So this means either x is 0, this means x minus 1 is 0, or x plus 1 is 0. And you solve these ones. Let me just go ahead and write this one is x is equal to 1. This one is x is equal to -1. So we found the values which make the x cubed minus x 0. What are these numbers? -1, put them in the right order here. And -1, 0, 1, these are values for x. It's starting from -infinity up to plus infinity. And then choose test values. Here I can put -2, I can put here negative 1 over 2. I can put 1 over 2 and I can put 2 here. And then values of the function at that point. So negative 2, I will do with the red one. Negative 2 cubed minus negative 2 is negative 8 plus 2, which is negative 6. This is a negative number. Means what? Means this piece is negative. We already know that at negative 1 this is 0, at 0 it is 0, at 1 it is 0. So for that piece is negative, we plug in 1 over 2 there, so negative 1 over 2 minus negative 1 over 2. This will give us 1 over 8, negative of that, plus 1 over 2. You find the common denominator here. You notice that, well, we are getting a positive number. So in this case, it is 4, and this is 3 over 8. This is positive. So this will be positive. You plug in a half there. That will give us actually negative 3 over 8. And that is negative. The last value would be positive. So evaluate that basically as 2 to the power 3, then 2. This is just 6, which is positive. Well, okay, so we find the sign table, but what are we interested in is the parts which makes x cubed minus x bigger than or equal to 0. So let's just see. It means that it's positive parts equal to 0. Should I include 0? Yes, it is equal to 0 here, here, and here. So it means that the parts which makes x cubed minus x bigger than equal to 0 is negative 1 to 0, and or find the union of that from 1 to plus infinity. This is the domain of the function h, which we wrote in terms of 2 intervals. Let us do this this one. Again, we have square root and we have denominator here. So the first thing here is that we want to make sure that the denominator is non-zero, and then the second thing is that the whole thing under the square root is bigger than equal to 0. Okay, so we again can do this whole thing by looking at the sign table of x plus 1 over x minus 2. You will see how that will include this piece also. So in this piece, you find all the factors of the numerator and denominator. So this gives us x equals to negative 1, x equals to 2. Then we have the table x, and we have negative 1 here, 2 here. At negative 1, when we plug in, the numerator is 0 and denominator is negative 2, so this is 0. At 2, however, 2 makes the denominator 0, so it means that it is not defined. So for x equal to 2, we don't have that value. Okay, then choose sample values. For example, 0 here, 3 there, and then negative 2 there. Evaluate x plus 1 over x minus 2 at negative 2. So it will be negative 2 plus 1 over negative 2 minus 2. This is negative 1 over negative 4, which is 1 over 4. This is a positive. So this will be positive. At 0, 0 plus 1 over 0 minus 2, which is negative 1 over 2. This is a negative, so this is negative. And at 3, 3 plus 1 over 3 minus 2, this gives us 4 over 1, which is a positive value. So from this, we are looking for the part which gives us bigger than and equal to 0. So first let me write this there. So this is this piece and that piece, positive 1. We need to include the 0, 1. So it means that we have to start from negative infinity up to negative 1, including. And from here, 2 cannot be there. At 2, the function is not defined up to plus infinity. So this is domain of the function g. And for the last example, we have this thing. So we see that the whole thing cannot be 0. That's the first thing. The denominator cannot be 0. But square root of something is non-zero if and only if that thing is non-zero itself. Yeah. On the other hand, we know that x squared minus 1 is under the square root, so it must be bigger than equal to 0. So it must be bigger than equal to 0 on one hand. On the other hand, it cannot be 0. That means that we should find where this guy can be strictly bigger than 0. Not bigger than equal to, just strictly bigger than 0. Well, again, sign table. Find the sign table of that. Well, x squared minus 1 is 0 means that x minus 1, x plus 1 is equal to 0. And that gives me x minus 1 is 0 or x plus 1 is 0. From this, we find the roots of that guy, x. And then we can put x squared minus 1, x here. X can go from negative infinity, negative 1, 1 to positive infinity. At negative 1, this is 0. At 1 is a 0. And the test values, this is negative 2, this is 0, this is 2. Now let's evaluate. Negative 2 squared minus 1 is 4 minus 1, which is 3 positive. So this part is positive. At 0 squared minus 1, this is 0 minus 1, which is negative 1. This is negative. This part is negative. And for 2, again, we have 3, which is positive number. We put positive. Which part we were looking for? This is the restriction, the only restriction we have to make sure happens. So it means that we are looking for only positive parts, not including the zeros. Okay? And that means that we can plug in any number from negative infinity to negative 1 and from 1 to plus infinity. Make union of those. This is domain of this new function. So I hope that you have seen at least refreshed your finding sign or solving inequalities and solving equalities for some basic cases in this example. And everything, again, finding the domain, everything comes down to 2 restrictions so far. Under the square root cannot be negative. The denominator cannot be 0.